Today's lesson will be on the mean value theorem, which is a very important theorem in calculus. So basically what it says is if you have a smooth and continuous function, which you know means that it must be differentiable at all points, and if you also have a closed interval, so for instance from A to B, then something really cool will exist where there has to be some place where the slope of the secant line is equal to the slope of the tangent line. So for instance, let's say we have a function, just some little piece like this, that starts here at A and is on this closed interval from A to B. And it's smooth and it's continuous, so we can apply the mean value theorem. So if I do the slope of the secant line, that's going to give me just this line right here. And we can find that easily enough by just calculating our slope formula. And then I see that if I could draw just like one tangent line here, parallel, that would mean that they would have the same slopes. So here's my tangent line. We'll say that this happens at C. So basically, the derivative at that point C has to be equal to, these two things are going to be the same because the slopes are parallel, which means the slopes will be the same thing. So this is the mean value theorem. So what it is that we're looking for is what C value will make this happen. So let's do an example. If I take my function f of x is equal to 5x squared minus 3x minus 2. I know that that's the equation of a parabola, so I know that this is smooth and continuous, which means it satisfies the first condition. I can take the derivative anywhere. And all I need is a closed interval. So let's say I'm just going to use an interval from 1 to 4. Any closed interval I want is going to be fine, because this is always going to be a continuous function. So let's say I do a graph of this function. Now I evaluate the function at -1, and the function evaluated at -1 is 6. So this looks like this. And then I evaluate the function at 4, and that's way up here at 66. Not drawn to scale. So I know that it's going to be some sort of parabola that looks like that. So if I find the slope of this secant line right here, then it appears that there's also going to be some point down here where these two lines will be parallel, giving me basically mean value theorem. So let's evaluate what that slope is equal to. So the slope of the secant line all I have to do is the change in y over the change in x. That has to be equal to the slope of the tangent line, which we know now is really just the derivative. So I'm going to take this derivative, set these two things equal, 10x minus 3, which means that this part over here is equal to 12, and I just set these two things equal 10x minus 3. So now all I have to do is solve for x. So I'll add 3, I get 15 is equal to 10x, and then I get x is equal to 1.5. So that means right here, this must be the point, 1.5, where that means that the derivative at 1.5 is equal to the slope of the secant line. This slope is 12, and this slope is 12. Okay, so let's pause.